Students should be able to approximate the value of an irrational number by comparing the radicand to perfect squares and estimating the root using a number line. By 8th grade, students should have mastered finding the square root and finding values on a number line. They have also learned how to find the square roots of perfect squares on a number line. We're joining this class as students are discussing their notices from the Pythagorean square activity. Students were provided with linking cubes and asked to extend a given pattern which highlights perfect squares in their lengths or roots. More about this activity can be found on the blog Elementary Teacher in Middle School using the link below or the QR code in the corner. As you listen to students' conversations, record what you notice about students' thinking. As you guys were constructing this, Ilani?
I noticed that there's a pattern of numbers.
Okay. What pattern of numbers do you see?
Well, on the ends, I see that they're going in order from 1 to 6.
Okay, 1 to 6. Did anybody else notice that pattern?
Yes.
Yes.
Okay. All right. What else did we notice?
They get bigger as you go up.
What'd you say, Ashton?
They get bigger as you go up.
What do you mean they get bigger as you go up?
Like if you go like from here up there, the
All right.
lines get bigger.
Wonderful.
The same colors, they multiply.
Okay.
Oh, yeah.
All right. So he's saying the same colors, they're multiplying together. So if I look at yours over here, he's saying you pointed here at 3 times 3. And if we were to do 3 times 3, what would that give us?
9.
9. Okay. Somebody else tell me what you noticed. Go ahead, Mackenzie.
Like diagonal, each of them makes squares.
Fantastic. Did anybody else notice that diagonally?
Yes,
or-
I did. Yes.
That was a good observation. Thank you, Taylor. I want you to take your perfect squares from that of our larger Pythagorean square, and I want you to order them from least to greatest. Take your perfect squares out and order them from least to greatest. Spending some time in the concrete phase of learning activates prior knowledge as well as builds students' understanding of the concept. Have students use a strategy called place and space. This requires students to place the perfect squares in order from least to greatest, then space them using number sense.
25, 36.
If not, you can adjust it. What'd you do that for?
This one's 25, 36. That's
Are you guys okay with your spacing?
Yes.
Okay. What is this one right here?
36.
36, and this one is
25.
And so you would say 16 is a little bit closer to 25 than 36 is? And what would make you say that?
Because the perfect square of 25 is 5. Wait.
Okay.
Yeah.
But what would make you say that this distance right here would be shorter than this distance here?
16 is close.
Oh, okay. So like if you had it on the number line. Okay. What's your largest perfect square?
16.
16. Okay. And what's the length of that square?
4 and 4.
Okay, 4 and 4. Irene's group, what's your largest perfect square?
36.
Okay, and what's the length of that perfect square?
6.
Okay, so we're talking about the length of our perfect squares. We notice that each of our perfect squares, each side has the same amount, the same length. We're going to start referring to that as the square root. So whenever I ask you what is the square root of your square, I want you to tell me the length of that square. Okay, so find your square that has 4 total tiles in it. What is the square root or the length of that square?
2.
The one that has 4 total tiles in it.
Oh, 2.
Students have now ordered from least to greatest perfect and non-perfect squares. You want students to use the root of the perfect squares to determine the root of the non-perfect squares. Listen as this student explains how she used what she knows about the perfect square before 6 to estimate the root of 6.
You know that this one's 2 and it's kind of closer. It's not going to give you 2 because we already know that 4 is square root is 2. So since it's closer, it's going to be like steps from the next number.
Nice, very nice thought. So if we try to figure out the steps from the next number, as you put it, how could we do that? What do you think we could do to figure that out? How many steps it is away from the next number?
Make a number.
Yeah.
Make a number line or count.
Okay, we can make a number line. Listen carefully to students' explanations. Do you hear mathematical language? Are students attending to precision when explaining their thinking? This may be connected to a lack of understanding of the concept. Students should know and understand the square root identifies or approximates the length of the square.
The square root of 3. So I think it would be 3 with square root of 2.
Okay, so you said it falls in between the square root of 2 and the square root of 3.
Yeah.
So you think it's going to be more or less than the square root of, well, this would be the square root of 4, right?
Yeah.
Okay. Moving into the representational phase of the concrete representation abstract model, students show their understanding on a number line. This clip demonstrates the use of a double clothesline number line, which allows the numbers to be easily manipulated. Watch as students place and space the radical numbers. Listen for McKenzie's strategy. Think about how can McKenzie's strategy help determine the approximate root of a non-perfect square.
4, 5, 6, 7, 8, 9.
Interesting. And why were you doing it like that?
Because that's the distance between.
That's the distance between those perfect squares. I think that's a great strategy. All right, we agree?
Yes.
All right, do you feel like it's spaced appropriately?
No.
Do we need to shift any cards now that that's up
I
there?
feel like they're not like any more like 6. Because the only number between 4 and 6 is 5.
Okay, so Diane said now the number between the square root of 4 and the square root of 6 should be the square root of 5. Nice thought. All right. The bottom number line will house the root of each perfect square, which will be used to estimate the square root of 6. Using a written number line, students should place radical numbers, which are perfect squares, along with the roots of the perfect squares. Students can then plot the non-perfect squares on its approximate location on the number line based on the location of the perfect squares. Students should understand they may not be able to identify the exact location and that determining approximation is acceptable. Students should use the distances between the first perfect square and the non-perfect square. This represents the partial distance between two perfect squares. Students should also determine the whole distance between two perfect squares closest to the non-perfect square. Counting the distances requires attending to precision as it will throw off the approximation as evident in this student's work. Notice how this student accurately counted the distance and estimated the root of 6 to be 2 2/5. She determined based on the information on the number line, the square root of 6 must be greater than 2 but less than 3. The partial distance from the radicand of 4 and the radicand of 6 is 2. The whole distance between the radicand of 4 and the radicand of 9, both being perfect squares, is a whole distance of 5. The student converted the fraction into a decimal and concluded the square root of 6 is approximately 2 4/10.